As we evaluate the American workforce in 2026, one metric overrides all others. The average adult attention span has fallen to exactly 8 seconds. In a standard office environment, employees are now switching between tasks and applications 37 times an hour. That is a forced context shift every 2 minutes. Clinical psychologists refer to this specific exhaustion as AI brain fry, a state of profound digital fatigue caused by continuous sensory overload. This cognitive load is heavily amplified by work slop. The flood of low-quality AI-generated emails, documents, and presentations forces the brain to filter massive amounts of irrelevant data just to extract minimal value. The result is a documented public health crisis. 61% of adults now meet the clinical criteria for internet addiction, and heavy users exhibit a 2.5 times higher rate of clinical depression. This systemic collapse represents the successful structural hack of human neurochemistry. Tech firms have spent decades optimizing algorithms to overwrite individual discipline with predictable biological responses. The primary target of this engineering is the mesolimbic pathway. This neural network begins deep in the midbrain at the ventral tegmental area and projects forward to the nucleus accumbens. Along this route, the basal ganglia acts as a strict biological gatekeeper. It determines what information is relevant enough to enter your working memory and what should be blocked out as noise. Inside the striatum, this gate is controlled by 2 competing sets of dopamine receptors. D1 receptors form a direct stimulatory pathway that initiates action, while D2 receptors form an indirect inhibitory pathway that suppresses it. Dopamine rarely functions as a simple pleasure chemical here. It operates as a computational tagging system. It signals the brain exactly which stimuli are highly salient, making it the ideal access point for external software control. To exploit this system at scale, platforms deploy deep reinforcement learning frameworks known as Dopamine Agents. These AI systems do not wait passively for input. They proactively structure content to maximize time on screen. They accomplish this by targeting reward prediction error, the exact biological mechanism that drives reinforcement learning and the formation of habits. The reward prediction error equation calculates the difference between the actual reward received, the discounted value of future states, and the initially expected value. When the actual reward exceeds expectations, the brain physically updates its expected value, reinforcing the behavior. Dopamine agents use probabilistic reversal learning to ensure the user never fully adapts. The moment engagement metrics indicate a drop in interest, the agent shifts the reward schedule, delivering high-value stimuli at completely unpredictable intervals. This dynamic adjustment creates a bottomless bowl architecture. Because the timing and intensity of the reward remain unpredictable, the dopaminergic surge never plateaus. Silicon dopamine agents are not predicting user behavior, they are dictating it. They trap the basal ganglia in an inescapable computational loop of continuous wanting. To see why this loop eventually breaks human cognition, we have to separate dopamine into 2 distinct operational modes, tonic and phasic. On the left is tonic dopamine, a sustained baseline pool in the prefrontal cortex, essential for sustained focus. On the right is phasic dopamine, transient high-amplitude spikes triggered by digital rewards. As continuous artificial phasic bursts fire, they actively drain the tonic supply. Without that tonic baseline, the prefrontal cortex loses its ability to exert executive control. The user physically loses the motivation to stay on task, unable to resist the next digital interruption. What we call AI brain fry is the measurable physiological cost created when software over-harvests the brain's short-term phasic reward system at the direct expense of its long-term tonic stability. In a clinical setting, chronic exposure to these algorithmic engagement loops results in reward deficiency syndrome. This condition induces a persistent hypodopaminergic state. The brain recognizes the constant overstimulation and attempts to protect itself by suppressing its natural reward pathways. As dopamine receptor sensitivity drops, the user requires increasingly intense, high-arousal digital stimuli just to achieve a baseline sense of normalcy. This biological rewiring creates a massive gap between intention and action. Survey data shows most users actively want to disconnect. Yet the number of 16 to 24-year-olds checking social media more than 10 times a day increased by 15% leading into 2026. As the threshold for stimulation rises, the global motivation to engage in ordinary, low-dopamine tasks, like reading, deep work, or face-to-face conversation, collapses. Users rarely abandon these platforms through willpower alone. The algorithms have successfully altered their biological hardware, making digital addiction inescapable without strict external behavioral intervention. The severe cognitive toll has triggered a cultural pivot. A growing demographic, categorized by researchers as the Luddite class, has declared 2026 the year of analog and offline. The most visible strategy is the absolute abandonment of the smartphone. By switching to dumb phones with physical buttons and low-resolution screens, users hard-code a limit on their behavior, permanently eliminating algorithmic discovery feeds. For those who must retain smartphones for work, abstinence has become standard practice. Users deploy strict gatekeeper apps like Opal and Freedom that execute unbypassable blocks on specific platforms. Attention is actively being redirected toward tactile, high-effort physical hobbies. Activities utilizing mechanical equipment force the brain into manual processing states that operate entirely outside of the digital ecosystem. This demographic intentionally avoids AI recommendation engines, relying instead on linear, organic discovery methods like word of mouth or physical browsing. The 2026 digital detox movement functions as a necessary biological intervention. By intentionally removing the digital interface, users are physically shielding their neural reward circuitry from hostile algorithmic architectures. The clinical antidote to reward deficiency syndrome requires a hard reset. Neurologists identify a strict 72-hour period of total digital detox as the minimum threshold needed to initiate recovery. During this offline window, the brain begins to slowly upregulate its dopamine receptors, gradually restoring the prefrontal cortex to its natural tonic homeostatic setpoint. The software market is reacting to this shift. While dopamine agents continue to optimize for retention, a new class of minimalist assistants like Lindy and Nextdocs is gaining traction by promising the exact opposite: minimal time on platform and zero visual interaction. The standard for enterprise software is shifting towards invisible interfaces. These tools execute complex tasks in the background, utilizing minimal visual interaction to ensure the user's mesolimbic loop is never triggered. Technology design is hitting a hard biological ceiling. Success in the next decade depends on a transition from over-harvesting the human reward system to protecting its strict, finite limits.